Well, hi, here comes example 2. And this one has another slight twist to it. We're going to take a derivative, of course. We're going to do it implicitly, and we're even doing it at a point. But I'm going to ask for the equations for tangent and a normal line. Well, let's get to business first. Let's go ahead and derive this implicitly. Here's our equation over here. And it looks like we're probably going to need to use, I wonder which rule. Possibly the product rule. Sounds like a good idea. So what I'll do is I'll go ahead and take this derivative, the derivative of x times cosine of y plus the derivative of cosine y, that's a long one, times x equals the derivative of 1, which is a constant. So we've got that. And as we learned in our last video, sometimes it is easier to just go ahead and plug the numbers straight in here. For example, I might put in pi over 3 where there's a y value. I might put in 2 where there's an x value, thinking that this will make all of this a little easier. So let's see, we have 1 times cosine of this minus sine of pi over 3 dy dx times 2 equals 0. Well, with a little bit of quick math here, if you remember your unit circle values, you'd realize that we're dealing with 1/2 and root 3 over 2. The root 3 over 2 times 2, well, that simplifies a bit. And hey, anyhow, we get down to the derivative, which is 1 over 2 root 3. Not a very exciting or interesting numerical value for the derivative, but hey, you know what? It's all right. I'm game. Now, as far as tangent lines go, I think you've done that before, and we even know what the slope of a tangent line is. It's really easy. That's the derivative at a specific point. So using point slope formula, y minus y1 is equal to the slope times x minus x1. And congratulations, there we go. We are actually done with the equation for the tangent line. Excellent, woohoo! But now comes this other word, this word that maybe you haven't heard, the word that is normal. So what we got here is a special kind of definition. A normal line is one in which you are perpendicular to the tangent line. Whatever your slope is for a derivative, that's the slope of your tangent line. The normal line is just perpendicular. Perpendicular. And it just so happens that when it comes to perpendicular slopes, what we're looking for is the, let me get this down, the negative reciprocal. That's right. Perpendicular slopes are going to be negative reciprocals of each other. Why do we do that? What do we need this normal force for? Well, perhaps what you need is to take a physics class, because normal forces can be used for centripetal forces. They can be used for magnetism and, well, let's just put it this way, electromagnetism, some flow rate states. There are lots of applications for them, and all it means is you have a force that is going perpendicular to the direction of travel. There really is nothing special about finding the equation for this, and if you want to put it in y equals mx plus b, be my guest, but that's extra work, and please don't make a mistake while you're doing it. But all you have to do is, if you see something about a normal line, take the negative reciprocal of your derivative and use that as the slope. Otherwise, you're just writing a line using point slope form. That's it. That's how we do the tangent and normal lines, and that's all for video 2.